Hey everyone, welcome back. This is Vivek Bharata. In this video, we are diving into setting up a Kafka cluster in KRaft mode completely without Zookeeper. We'll start with the setup from the previous videos where Kafka was running with Zookeeper with the Docker Compose file. But now we are switching into KRaft mode, Kafka's new built-in consensus mechanism. Here's what we'll cover in this video. Setting up Kafka in KRaft mode from scratch, exploring two KRaft deployments, combined mode and split mode, validating the whole setup by creating two topics with different partition configurations. This is already covered as part of the previous videos where we have init.js. It will make sure that the required topics and partitions are created. Then we'll use Kafka UI to verify everything is working as expected. Even if you haven't watched any previous videos in this Kafka Zero to Hero series, don't worry, I'll make this tutorial easy to follow so you can jump right in. Let's get started. So what exactly is KRaft or KafkaRaft? Which is a built-in mechanism inside Apache Kafka itself that replaces Zookeeper for metadata management and controller election. It uses the Raft consensus algorithm to manage metadata natively within the Kafka itself. That's all we need to know as of now for the theory part. Let's start with the existing setup. I'll just give a high-level walkthrough of the current setup. So over here, we defined in the Docker Compose file Zookeeper as one instance from Bitnami Zookeeper, and all the necessary environment variables and ports 2181 is exposed. And we have Kafka 1, Kafka 2, Kafka 3. In the previous video, I covered multiple brokers where Kafka 1, as you can see here, 3 brokers are there. So in the overall Kafka cluster, we set up the Kafka 1, Kafka 2 and Kafka 3 as a 3 broker system, which altogether coordinates and decides which broker will be a leader for a partition for a specific topic. And we have Kafka UI, where it's kind of a user-friendly, lightweight Kafka management tool, you can say. Okay, and we need all the different environment variables set up in a way that all 4 services, all 5 services technically are collectively working together to basically have the whole Kafka cluster set up in your local machine. I'll just walk you through on the first Kafka instance itself, so it will be similar. Image Bitnami Kafka, container name, ports 9094. This is all the set of environment variables we need. But overall, if you see here, Zookeeper connect. So this is the value points to the Zookeeper instance. Okay, and we have the default environment variables for the listeners, advertised listeners, and we defined 3 important environment variables. One is default replication factor. So this default replication factor is basically whenever you create a topic, you can mention what is the replication factor. So with this environment variable, if at all when creating a Kafka topic, if no one mentions the replication factor, it just fall back to this number, that is 3. Okay, then in-sync replicas again. So this is like a minimum in-sync replicas. So this minimum in-sync replicas meaning producer will receive the acknowledgement only when that specific message is replicated in 2 instances over here. Offsets topic replication factor, this is an internal topic one, you could ignore for this specific video. And over here depends on Zookeeper service, and Kafka 2 also similar, Kafka 3 also similar. One small important point to be noted over here, the external value is an incremental series. So Kafka 1 9094, Kafka 2 9095, Kafka 3 9096. That's it. The containers are already running, as you can see over here. I already opened the Kafka UI as well, so let me just quickly refresh. So in this Kafka UI, you can see number of clusters, and right now it's only one cluster that is self-explanatory, which is pointed to the local cluster from the Docker. Alright, so over here if you see ports 9092, which is an internal port again, and host Kafka 1, Kafka 2, Kafka 3. All this we mentioned in the Docker Compose definition for the Kafka UI over here. Kafka cluster 0, bootstrap servers, Kafka 1, Kafka 2, Kafka 3. Okay, that's pretty much it over here. So in this, out of these 3 brokers, as of now active controller is 3rd broker. Okay, and topics, I guess it's all empty, so let me just create the default setup. And now once we refresh, as you can see, 2 topics already created with this init.js, order.created, 3 partitions, user.updated 1. For the new users, let me see if I can. For the new users, I'll just walk you on this one. So we are using Kafka.js for the JavaScript client library. We have 2 topics to create, and this is simply the definition where we create, and as you can see here, we mentioned replication factor and the number of partitions for the specific topic. It's a simple Kafka JS setup tool, and we are connecting actually with a Kafka admin client instance. That's it. Okay. Now, if we go to the Kafka UI, so for this order created, we have three partitions. So let's go inside and see which partition, which broker is acting as a leader. Okay. So in this table, if you see for partition 0, okay, the green color which you see, this is like a broker. So first one, for the partition 0, broker 3 is leader. For partition 1, broker 1 is leader. For partition 2, broker 2 is leader. That's it. Okay, I hope this is clear. If you guys need a fundamental part of what exactly these are, brokers, topics, partitions, and all that stuff, I would highly recommend to watch the first video in the series. That will really help you to connect all the dots. So all this is just to set the context for the KRaft mode. So let's dive into that. So the first and foremost change is, as you guys are already expecting, let me just hide the terminal. We can remove this Zookeeper definition all in all. That's it, simple. Okay, so let's remove this one. We'll start with one by one. With Kafka 1, so the first setup is basically to cover with the combined mode. So what exactly is combined mode? KRaft, actually the service which is part of the current Kafka container itself. So KRaft can stay inside, and we will mention, okay, this specific Kafka 1 instance will act as both broker and also as a controller. So if you see, these two are redundant, which are not really required now because we are going away from the Zookeeper. So we can just remove these two over here. All right. However, we need to set new environment variables to make it work with the KRaft mode. I'll just paste the values over here. So over here, if you see, this Kafka CFG is basically the bitnami of defining the environment variables. But if you see here, node ID, which is important and should be unique for each node in this whole Kafka cluster. So as it's the first one, let's start with node ID 1. And if you see here, process roles. So this is the identifier which will decide this specific service, Kafka 1, will act as a broker or a controller or both. So as we need to cover first as a combined mode, so we'll just define it as controller and broker. So this specific instance will act as both controller and also broker. Okay, now the next important environment variable is controller quorum voters. So this is basically, we'll define all the controllers. If you can see here, there is a pattern over here. So this is the ID of the node. As you can see here, node ID. So this is important. So we need to mention 1, which is a node ID of this one, and Kafka 1 host, and also the 9093 of the controller listener name port. So if you see here, controller, we define it as 9093, right? So we need to mention in the same fashion. So Kafka 1, and as it's a controller, we should access that with the defined port, that is 909. And this 9093 can also be changed, but as you're following with the same pattern, so we'll just use this 9093 port. And if you see, as we'll be maintaining 3 controllers in this combined mode, so we'll just cover the second and third Kafka instances, but I just written it as 2 @Kafka 2 9093, because for this Kafka 2, we'll set CFG node ID as 2, and for 3 it will be 3. Okay, and then controller listener name. So this is again for the identifier to understand, okay, what is the actual listener name to access it as a controller, right? So we'll just mention this as controller. All right, so these are the 4 parameters, 4 environment variables that we need to set as part of the KRaft settings. And let's just add another comment stating listener setting, so it's easy to read. So all these are the existing listeners. We really don't need to change over here. And we need one more block, that will be cluster settings. If you see here over here, so in the cluster settings, another new environment variable we added is KRaft cluster ID. This is really important. Otherwise, all the services, if you spin without this env variable, try it out and let me know in the comments. If you do without this one, it will eventually can't decide, because all instances will randomly generate the different cluster ID, and no one will be as a leader, and it never spins up, that's for sure. Okay, so KRaft cluster ID, which is important, and this will be has to be same for all the nodes in the Kafka cluster. All right, that's pretty much it. We need to change for the environment variables. Only with the environment variables, this Kafka 1 instance now acts as a both controller and a broker. Controller as in again the KRaft controller. That's it. Okay, I'll just override this Kafka 2 and Kafka 3 quickly. if you look at the chain set also, it's self-explanatory. We removed few environment variables and added few, and the importance of each new environment variable. Okay, so for the Kafka 2, node ID is 2, and also we should make sure that is also aligned. So host, like domain name over here, is Kafka 2 and the port is 9093, which is a controller port. Okay, and cluster ID has to be same, so cluster ID 1 over here, and for the same Kafka 3 instance, node ID is 3. Let's make sure 3 at the rate Kafka 3 9093, and cluster ID is 1. That's it. And over here on the depends on, we can just remove Kafka Zookeeper. That's pretty much it. Okay, so looks good. So let's fire it up and see how this thing builds up. Before even that, let's stop the old instances, and let's just delete the whole containers. Okay, Kafka 3 is down. Sure, if I can just scroll it up. I just zoomed in for the video, but I think all stopped, so let's scale it up. All right, so let's start docker compose up -d. Let's see how this thing. Oops, we got this error. Kafka 1 depends on undefined service zookeeper. I see. I think we missed to remove this one, so we can just remove this depends on flag over here. That's pretty much it. Yeah. Okay, cool. Let's fire it up again. All right. Looks like it created all the instances as start. Let's go to Docker desktop and see exactly going on. Kafka 1, let's see the logs. Looks like it all settled. Kafka 2 also settled. Quorum controller ID 2, and yep, all looks good. So if you see, there's no Zookeeper. All three services, Kafka 1, Kafka 2, and Kafka 3, are acting as three controllers and three brokers. Let's go and refresh the Kafka UI. Let's look at the dashboard. As we deleted the whole things, topics and everything should be empty. Let's see, topics are empty. Brokers over here, if you see now, 9092 port, there's the local host the Docker locals network host, Kafka 1, Kafka 2, Kafka 3. Okay, so over here right now, if you see, we have three brokers, right, with IDs 1, 2, 3, and this checkmark is nothing but the active controller. So out of the three brokers, one broker will act as a main controller. Okay, that decision will be done by the KRaft service inside each of the brokers. So I think it's kind of a confusion right now, but believe me, once I complete the split mode, it will be a bit more easy. But over here, if you see, we have three brokers. Each broker is acting as both controller and a broker instance. Yeah, so three Kafka services: Kafka 1, Kafka 2, and Kafka 3. Over here, right? Kafka 1, Kafka 2, and Kafka 3. All these three services are acting as brokers, which are like a Kafka brokers, and also as a controllers. Okay, these controllers is again nothing but the KRaft controller mode. Okay, on top of it, out of these three controllers, which can also be one controller by definition, like for the small projects and all, but for production it's always better to have it as a three broker setup and also three controller setup, or it can be five, basically odd number of instances. Yeah. So just to reiterate, three Kafka instances are there: Kafka 1, Kafka 2, and Kafka 3, where all these three services are acting as both controllers, KRaft controllers, and also brokers. So these three KRaft controllers combinedly take a decision to elect which broker should act as a controller. That's it. Okay. So if you look at the Kafka UI side, as of now, this broker 2 is acting as a active controller. Okay, let's run the init script one more time. Okay, created true. So let's look at the topics. Let's refresh once. It will take a while to adjust accordingly. Let's see, Kafka 1 logs looks good. Kafka 2, unknown topic ID from leader, but let's see. I think this will be resynced. in the next heartbeat. Oh yeah, we can see order created as one topic name, user updated as another topic name. Partitions for order created is 3. So let's get into the order created and let's look at the replica's definition and also who is the leader. So for partition 0, broker 1 is the leader. For partition 1, broker 2 is the leader. Okay. And this is the replica configuration, 3 replicas. And if you look at the other one, user updated, it will be only, yeah, replication factor is 3, but partition is only 1. So only we have one partition, which is partition ID of 0, and third broker is acting as a leader for this specific partition. That's it. Okay. So if you see here, there's no Zookeeper service. Everything is running in-house for the specific Kafka instances. I hope this is clear. Now let's move on to the next mode, that is split mode. So what exactly is split mode? Split mode is nothing but over here, each instance is acting as both a controller and a broker. So what we'll do, we'll keep this as is, but we'll remove this controller mode from these Kafka 1, Kafka 2 and Kafka 3 instances, and we'll create another instance which is actually like a controller Docker service where only that specific instance acts as a KRaft controller. Rest all these 3 instances will act as a plain broker services. That's it. For that, let's copy paste this file Docker compose. So we'll just have it that as a backup and we'll rename this to Docker compose split mode. All right. So for that, we'll start with we'll name it as controller 1 and image would be same. Okay. And no need of exporting port for this controller. Next, I'll just dump all the environment variables required and I'll just give a walkthrough of this. So again, as this is the first instance, first node service, like first service in the Kafka cluster, let's name this as node ID as 1 and we'll rename the other instances down. Okay. So node ID is 1 for the controller 1. Okay. And this process roles, if you see, which is only controller, not like a controller and broker. So we just define it as controller. And right now, which is only one controller, so quorum voters is 1, which is an ID, node ID of 1, and the instance accessibility is, let's name this as controller over here, controller 1 @ 9093. Okay. If you see, the business is configured the name as controller and port is 9093. So that's how we define over. That's what we define over here. Simple. Okay. This is all similar, just that we are not exporting any external and plain text because this is basically the purely internal service. Okay. And then cluster ID, again we need to maintain this across all the nodes. Okay, that's it. So this is the simple service, controller 1, which acts as a simple KRaft controller. That's it. Now let's tweak the other instances to support this external controller. And the first and foremost thing we need to do, we should remove controller role from the Kafka instances. We just removed from Kafka 1. Let's see. So node ID should be 2 because we already defined node ID as 1. If you try to start the services with the same cluster and the same node ID, it will fail. Okay. So node ID is 2. This one is set. And over here, if you see, we don't have 3 controllers, right? We have only one controller we are defining. We will go to the 3 controller mode in the later part of the video, but right now it's only one controller, right? So controller 1. So here we can just remove everything till here and we can say controller 1. That's it. Rest all stays as is. So let's update for Kafka 2 also. Node ID will be 3. No need of controller as a process role. And we can just copy paste this 1 @ controller 1 colon 9093. All right. Let's move on to Kafka 3. We can remove this controller as process role and node ID will be 4 and this will be controller 1 9093. Okay, and no need of any other changes needed. That's pretty much it. Okay, so before spinning up this one, let's stop and delete these instances. And as you can see, services are gracefully shutting down. Okay, let's delete this whole containers. Let's start this one. So with the Docker Compose, you can also mention with -f, we can mention the different YAML file instead of the default Docker Compose.yaml file. Okay, so this one is split mode.yaml file. I already have this as part of my history. We got this error, services.environment must be a mapping. I think there is some tab issue over here. Yeah. Okay, that's it. Right. Yep. Let's start again. All right. Let's see. So Kafka 2, controller 1, Kafka 3, Kafka 1, Kafka all are started. So let's look at the Docker thingy. Looks like there is an issue, right? Yeah, all Kafka instances got terminated. Okay, let's look at Kafka 1 instance logs and let's understand what's going on. So there is an error over here, illegal argument exception. Controller listener dot names must not contain a value appearing in the listener's configuration. Listeners dot names, okay, must not contain in the listeners. So this controller should not be there, yeah, because this has to be defined only for the controller over here, listeners definition for the actual controller, but not for the broker mode for the specific Kafka instance. Okay, looks good. Let's remove that for the Kafka 2 and Kafka 3 instances as well. Controller 9093 from the advertised listeners over here. Yeah, makes sense. Let's spin up again and let's see. Okay, all restarted and respective services again spinned up. Let's see. Okay, now let's look at, looks like all the services are up and running which are in green state. So let's just look at the Kafka one and see what's going on. Okay, Kafka server started. I think it all sorted. The issue got fixed. Let's see. Now we can just go to the Kafka UI, refresh once. Alright, now if you see here, earlier we have 1, 2, 3. Now the broker ID is changed because that's how we define in the Docker Compose file, right? So again, if you see here, in this case, second broker, which is of broker ID 3, is defined as an active controller. Alright, topics and all is empty. Now let's look at the logs from the controller 1 instance. So over here, if you see, there's some all the boot up information, all this looks good. Now what we'll do, we'll just run the init file again. Okay, now let's look at the logs for the controller one. So partition record, topic record for user updated, all that information. Now let's look at the Kafka UI again, and in the topics we can see order created, partitions 3, and over here partition 0, broker ID 4 is a leader. I hope this is clear till this part. Now if you see here at the Docker definition for this mode, let me just hide the terminal. Okay, so we defined controller 1 and the process roles, which is actually running in the KRaft mode, but only in the controller mode, not as a broker. But rest all the services are purely running in the broker, not just the combination of controller and broker. Okay, this is okayish for the local development setup, but if you look at the production level part, usually for a very heavy data volume, usually the number of clusters, the number of brokers can be more than 10, right? In that case, it's always better for fault tolerance and for the scalability part of it, it's always better to maintain multiple controllers like the KRaft controllers. So we'll just update this file, or maybe we'll just duplicate this file and rename to make it as a multiple controller setup. So over here we have only controller 1, we'll just make it as a 3 controller setup and 3 broker setup. Okay, let's duplicate this file. Let's make it as split mode with maybe as 3. Okay, now if you look at the part, we'll just copy paste this one, self-explanatory, right? So we'll just do and another paste. Okay, let's rename this to controller 2, this to controller 3, and the immediate change we need to do is node ID should be updated again, because the first 3 node IDs will be the controller nodes. Okay, And over here we need to update this configuration for all. That will be like 3 controllers over here, and already is 2 for this controller 2, and this is controller 2, and this will be controller 3. Okay, let's replace this for the controllers part. Okay, and then container name also, of course, so it should be controller 3 for the controller 3 instance. Okay, 1 at the rate controller 1.90 colon 9093, 2 at the rate controller 2, and this one, oopsie, this will be 3, yeah, over here. All right, this looks good. Now let's make changes for the Kafka broker instances as well. So now ready, of course, this will be 4. All right, and this one we need to update. Let me just update this to id 3, so this is proper. Let's rename this to other instances as well. Okay, and for the Kafka 3, that's it. And node id should be, this will be 6 Kafka 3 instance, and this will be 5. So overall it will start with 1 2 3, so till 3, all 3 controller instances and 3 broker instances, 4 5 and 6. Okay, I think that's all we need to change. If there is an error, let's see, we can fix that anyway. So let's stop this. We can use down command for the same, so it will just try to stop all the instances. I think it will mess up to some extent. Oh no, we created the new file, right? So it should be fine. So we clearly mention apply this for this specific file, like the docker compose file should be split mode.yaml file with this -f option. Okay, everything removed, looks clean. Now let's add another docker compose command, and that would be docker compose split mode with 3. This is the YAML file, right? -3. So yeah, let's do with up hyphen -e as a daemon thing. Let's see. Now if you see, total 6 services are running. Let's see, did we break anything or everything went smooth? So over here, if you see controller 1 2 3 and Kafka 1 2 and 3, let's open Kafka 1 and see where all the services are settled. Looks like, let's look at the controller 1, this also settled. Okay, looks good. Let's look at the Kafka UI side of it. Brokers, let's refresh one more time. Dashboard, we have only one cluster, and inside this local cluster we have these 3 brokers, and you can see the broker ID got reflected 4 5 and 6, and out of these 3, this broker ID 5 broker is basically acting as an active controller. Okay, don't get confused with this active controller broker and the definitions what we defined in the docker compose. So these are like the KRaft controllers which will collectively decide which broker should be an active controller. Okay, that's it. Looks good. Now let's run again the init.js. Okay, all good. Now let's look at the UI part of it. On refresh, I think broker ID got swapped, but anyway, active controller is 6 now. Active controller is 6 now. Broker count is 3, and another topics. Let's refresh. Will take a while, I believe. Let's look at the logs. In the meantime, Kafka 2 order created. Yeah, it should reflect. Let's see. Refresh. Yeah, order created. Total 3 partitions, and for this one, leader is 5. For partition 1, leader is 6. For partition 2, leader is 4. That is broker ID. ID is 4. Okay, so all looks good, right? So active controller is 4. Total brokers is count is 3 because we have 3 brokers, and total partitions 4. Why? Order created 3 partitions and user updated 1 partition. And over here for this partition 0 of topic user updated replica, broker 4 node id 4 is basically the leader for it. Okay, simple. I hope this is clear. So overall we covered 3 different ways of configuring Kafka cluster with 3 brokers, and again with the combined mode, split mode, and again in split mode either with 1 KRaft controller or 3 KRaft controller. This is again just to demonstrate. So in which scenarios, which type of definition we need. So there's nothing specific, but for sure fundamentally you should use this setup only for the very local development and for the development environments as such. However, for production it is always best practice to maintain 3 brokers as a bare minimum, and also as a thumb rule we should think for a more futuristic way and define the number of partitions as well, because again we can change the number of partitions, but it needs more heavy lifting on the Kafka side and all, and we need to prepare and plan for it more upfront. So it's always better to think for a bigger, like 5 years 10 years down the line, and assume that okay, how the data can be based on some different benchmarks and load testing and all that stuff. Define the number of partitions, and based on that you can define the number of brokers and replication factor and all that stuff. Okay, it's doable. Changing partitions is doable, but it's better to brainstorm it thoroughly and define a number, like even it's, let's say, 100 partitions, 1000 partitions, whatever it is, right? Based on that you can define the brokers and all this you can play around with a lower environment setup in one of your cloud provider, and accordingly you can narrow it down. Okay, resuming back to the production level, odd numbers is better. Number of instances, either it's a controllers or a brokers, 1 3 5 7, something like that. Okay, and also for the production it's always recommended to configure at least 3 controllers, KRaft controllers, rather than one. Again, one is only for the purpose of for the lower development and to make sure everything is working with the KRaft setup. That's it. Okay, I hope all this is clear. Let me know if you have any queries in the comments down below. And if you are watching this as a very first video in the whole Kafka Zero to Hero series, I would highly recommend to start from beginning so that you will get more understanding. Even if you are experienced, maybe just give it a shot. It will be kind of a revision for you. And this kind of a video I'm uploading after reaching 1000 subscribers. So I would like to thank everyone who actually subscribed and motivated me and supported me from day one. Thank you so much once again for reaching out the one big milestone, which is 1000 subscribers. Moving forward, I'm thinking to create some more videos on Kafka. Next topic most probably I'll do on the CLI. We never touch the CLI commands because in most of the times we are using Kafka UI, but it's always handy if you get to know the CLI, and I always prefer that. But earlier videos I did with Kafka UI, so it's better, easy to understand for the beginners and all. So most probably in the next video I'll cover Kafka CLI, more extensive commands and all that stuff. And later I'm thinking to plan it out for bigger real world examples, like for the event driven use case, and one for the log aggregation, and the other one can be analytics, like the real-time analytics and all that stuff. So let's see how this thing goes. But in the meantime, background, I'm also building some mini projects to basically help to make this real world examples more accurate. So yeah, stay tuned for the next set of videos. If you feel this video is helpful, make sure you hit that like button and subscribe. Thank you so much for watching, and I'll see you in the next one.